It's essentially a virtual coloring book. Picture a big screen. It has some coloring book images on it, and then a child can come up and press on it. And as they press on it, it essentially is coloring in the image. So you color it by scraping your hand over the top of it, and then you can press into it to change the tone of the color. The research that I do here at the University of Michigan is at the intersection of technology and childhood disability. So basically what we do is we use a different technology every semester in the class. And then I work with a specific disability and what the issues are related to that, and then we try to address that over the course of a semester. So the project that we had the pleasure of working on this semester, I worked with Dr. Sean Ahlquist from Art and Architecture and Dr. Sheila Omarin from School of Music. And essentially what we were trying to do is come up with a project that we could use for Dr. Ahlquist's 5-year-old daughter who is on the autism spectrum disorder.
Often there can be a challenge for children with autism that they don't understand the amount of pressure that they are applying to do certain tasks. Therefore, they can often use an inappropriate amount of pressure, whether it's too much pressure or too little pressure. With this technology, and this was really a kind of starting point, the textile, which can be designed as a stretchable surface, we can use that as a kind of gradation of input. So not just sensing when it's touched, but sensing how much force is being applied with each individual touch.
It's almost spring-loaded, but the springiness, the elasticity, is what's sewn into the material. And as you press in, it changes the color. Behind the screen is a projector projecting the image onto the screen. And then there's also a Microsoft Kinect sensor measuring the depth of pressure. And that's what changes the spectrum of color.
In collaborating with the engineers, I think it was a really exciting process. Certainly there's challenges in terms of engaging two very different skill sets. Finding the common ground for these two diverse fields to come together, I think, was a bit of a challenge, but for this project it ended up working out in quite an exciting way.
Essentially the students in the class were trying to come up with different devices to help with collaborative play. Interaction between parent and child. Per semester that this course is taught, we come up with 15 things that might help, and then we show it to the people whom it might help, and they say, thumbs up, thumb sideways, or thumbs down. My students are software developers. We try to learn a little bit from medical professionals, and then in a lot of ways we're just throwing spaghetti against the wall.
There's this common phrase that when you've met one child with autism, you've met exactly one child or one person with autism. The issues are very, very unique and very hard to translate from individual to individual. So what I think is really valuable with this research, not only the project, but I think also this methodology of research, is that we're developing tools that are made to be tuned to an individual child.
Where the electronic device is dissipating a lot of heat, and if the heat can't escape, that means the electronic device gets very hot, and when it gets hot, its performance suffers and it also can have a reduced lifetime. We invented a way